So in our third video in this series, we have seen or we've looked at non-annual compounding, where we are asked to calculate the future value from the present value, and simply we'll flip this back and calculate the present value from the future value when the compounding is non-annual, right? So let's just do a little recap. So with non-annual compounding, and we are asked to find the future value, the formula we used was future value after n years was the present value times 1 plus the stated annual interest divided by the number of compounding per year raised to the total compounding, mn, which is the number of compounding per annum, times the number of years, which gives us the total numbers of compounding. So just rearranging this will give you, now we wanted to calculate the present value from the future value. So we're just rearranging this, we'll find that present value is equals to future value after n years divided by 1 plus rs over m raised to the total compounding. Okay, so now with just simple math, where if we have 1 over a to the power of x is the same as a to the power of minus x, right? So using this power, we're going to bring it up. So the present value is equals to the future value after n years multiplied by 1 plus rs over m raised to negative mn, right? So now we're going to see an example where the investment is compounded non-annually, not only one time per year, and we're going to be calculating how much we should have invested, 10 years ago, maybe if n is 10 years ago, so that we have this amount of money at the present. So let's just import the example. All right, let's see the example. Let's just expand this a little bit so it's easy to see. So there's this manager of a Canadian pension fund, right? There's a fund called Canadian Pension Fund, right? So this there are people who are investing their money in this Canadian pension fund. Canadian pension fund. And this Canadian pension fund is required to make a lump sum payment or a one-time payment of 5 million Canadian dollars 10 years from now. 10 years from now. So we have our time. I usually write time here, but if we're talking about years, I can do year, and that's very intuitive. All right. And we have time is equal to 0, 1, 2, 3, 4, 5, 6 years, 7, 8, 9, 10. Let's just do 10. This is 10 years, and this is now. So his fund has to pay someone or a group of investors or a particular single investor, one investor. This fund has to pay this investor 5 million Canadian dollars 10 years from now. This is now. This is 10 years, right? In 10 years. This is 10 years. This is 10 years. So in 10 years, he has to pay Canadian dollar of 5 million, right? That's the problem. Now, This manager wants to invest this amount today, an amount that we don't know. Today, she wants to invest that amount today in some kind of investment, right? So that it will grow to the required amount in 10 years. She wants to invest X amount of money today so that in 10 years it will grow to 5 million Canadian dollars so that she can pay her investors, right? So that's the problem. Now we're trying to set up a problem. Now, the current interest rate on this investment, GIC, is 6% per year, compounded monthly. And how many months are in a year? 12, right? So this manager of a Canadian pension fund needs to pay her investors $5 million in 10 years, right? And she wants to know how much she should invest now into this GIC, another GIC fund that pays 6% per year interest compounded monthly, so that in 10 years she will have $5 million to pay her investors. So that's what this question is asking. And so for each year, first year, second year, third year, 10th year, so for each year, the interest rate is 6. The interest rate for this GIC investment is 6% per year, but it's compounded monthly. All right. So now we're going to use this formula. Let's first do so the future value. No, we are calculating present value, right? Our x and present value are the same. X or present value, whatever. That is, that she needs to invest today, is the future value after n years multiplied by 1 plus the stated annual interest rate divided by how many times it's compounded monthly. How many times it's compounded yearly to the power of minus mn. All right, so now what are these values? So future value n, that's 5 million Canadian dollars. Instead of n here, we can just say 10 because we know n is 10 years. What else do we know? The stated annual interest rate. We know that is to be 6% or 0.06. What else do we know? We know that this, whatever money she's going to put into this GIC investment, is going to be compounded at 6% 12 times a year. So the number of compounding per year is 12, right? And our n is, of course, 10 years. All right, now the only thing that's left is just substituting these in here. So the present value is simply the future value after 10 years, which is Canadian dollars 5 million multiplied by 1 plus the stated annual interest. The GIC people said, oh, we're going to pay 6% interest per annum. So that's the interest rate that they state. That's why this S means stated annual interest. So that's 6% divided by the number of compounding per year. It's compounded monthly. It's compounded 12 times a year. That means they are going to pay interest on this 5 million 12 times a year, raised to minus m is of course 12, n is of course 10. Now we're going to do 5 million 1 plus 0.005 raised to minus 120. Now this is Canadian dollar 5 million this is going to be 0.549633, and this will give us 2,748 and 163 and 67 cents. So this lady, this manager of the Canadian Pension Fund, needs to invest about $2.7 million in this GIC fund that pays 6% per year interest rate that's compounded monthly, so that at the end of the 10 years she will have 5 million Canadian dollars that she will pay to her investors. So this is what we mean by non-annual compounding, and using that non-annual compounding to calculate a present value from a future value.